Today's topic is potentiometry of electrochemistry. In this video, we are going to learn about the principle involved in potentiometry and the types of potentiometric titrations, instrumentation of potentiometry, and the electrodes used in potentiometry, and interpretations of different titrations and applications of potentiometry. Potentiometry is a technique that is used in analytical chemistry, usually to find the concentration of a solute in solution. I am repeating again. Potentiometry is a technique that is used in analytical chemistry, usually to find the concentration of a solute in solution. Types of potentiometric titrations. There are four types of titrations that fall under the category of potentiometric titrations. Number one, acid base titrations. Number two, redox titrations. Number three, complexometric titrations. Number four, precipitation titrations. The basic principle in potentiometry is an electrochemical cell's potential is directly proportional to the concentration of given sample. I am repeating again, the basic principle of potentiometry is an electrochemical cell's potential is directly proportional to the concentration of the given sample. This can be explained based on the Nernst equation. I have shown the mathematical form of Nernst equation here, and I have described the parameters present in this equation also. The instruments used in potentiometry are an indicator electrode, a reference electrode, a potential measuring device that is said to be potentiometer. Here, this is two electrode system. The potential difference of a full cell is given by the equation E cell is equal to minus E reference plus E indicator plus E junction, where E refers as potential difference. Here I have described what is E cell, what is E reference, what is E indicator, and what is E junction. Let us see the mechanism. The electrons travel from the reference electrode to the indicator electrode during the process. The negative ions runs towards the cathode. The positive ions runs towards the anode. Estimations. The endpoint is measured when there is a sudden change in the electric potential. This happens when a titrant is added to the solution sample because there is an alternation in the ionic activity and concentration of the solution sample. There are three elements in a basic potentiometric titration, that is, reference electrode, indicator electrode, and mechanical stirrer. The endpoint is determined when there is a rapid change in the solution potential. An electronic voltmeter used to determine the values obtained in the experiment. Now I would like to define all the four types of potentiometric titrations. Now first I will define or describe the acid-base titrations and redox titrations. The acid-base titrations. There is a change in concentration of H plus and OH minus during the neutralization of bases and acids. In this titration, a hydrogen electrode is used. The reference electrode is the normal column electrode. An acid of known volume is kept in a beaker with an automatic stirrer. The hydrogen chloride is linked to NCE through a salt bridge. Here NCE means normal column electrode. The hydrogen and NCE are connected to a potentiometer which tracks the EMF. Second type is oxidation reduction reaction. This is also called as oxidation reduction titration. An indicator electrode is used in the oxidation reduction titration. The indicator electrode possesses a potential directly proportional to the logarithm of the concentration of two oxidation states. This was explained in previous slide in the form of Nernst equation. Precipitation and complexometric titrations. Precipitation titration. An indicator electrode is made of metal involved in this reaction. The other type of electrode that can be used is whose potential is governed by the anion concentration that is precipitated. The solubility of the substance that is being precipitated determines the endpoint of the titration. Fourth type is complexometric titration. This titration is achieved by an electrode of a metal whose ions are involved in complex formation. For example, silver electrode titrates cyanide ions with a standard silver solution. The complex formation reaction is shown here. After reaching the equivalence point, silver cyanide forms a solid precipitate. After this point, adding silver does not change the concentration of the complex. If more than one complex is formed, the reaction becomes complicated. In this situation, EDTA can be used to handle. This is acid-base titration curve, which would be obtained in potentiometry during acid-base titrations. Redox titration curve obtained in potentiometry. Titration curve obtained for precipitation potentiometric reactions is like this. Titration curve obtained for complexometric titrations in potentiometry is like this. The following are applications of potentiometry. Detailed description is given. Acid-base titrations. Potentiometry is commonly used in acid-base titrations to determine the pH of the solution. Redox titrations. Potentiometry can also be used to perform redox reactions. Ion selective electrodes. Ion selective electrodes, which abbreviated as ISE, are electrodes that respond selectively to a specific ion in solution. Potentiometry is commonly used in conjunction with the ion selective electrode to determine the concentration of specific ions in a solution. Drug analysis. Potentiometry can be used to determine the concentration of drugs in biological fluids such as blood and urine. This technique involves the use of potentiometric sensor to measure the potential difference between the sample and the reference electrode. Environmental analysis. Potentiometry can be used to monitor the quality of water and soil. The technique involves the use of sensors to measure the potential difference between the sample and the reference electrode. By calibrating the sensor using known concentration of contaminants, the concentration of pollutants in the sample can be determined. Overall, potentiometry will have a versatile applications in different fields. Thank you. Happy learning.